Okay, good morning everyone. In the previous lecture, we ended with the first module, which is the matrices, theory of matrices. And now we are heading to the second uh, module, which is differential calculus. So, in differential calculus, the first topic that we will learn is the successive differentiation. So first of all, we will understand what do we mean by the successive differentiation. So successive differentiation is actually uh, like your higher order derivatives that you have seen. Like if I take y is equal to 2x plus 3x square, and then what do we have? So dy by dx will be equal to 2 plus 6x, and then d2y by dx square is simply 6. So this is what there was this higher order derivatives. Okay. So what you're doing, you're taking the derivatives successively. So if you take the third derivative over here, so what you will have d cube by dx cube, the derivative of this 6 will become 0. So this is called the successive differentiation. So you have a function, you go on taking derivatives of it, and that process is called a successive differentiation of a function. In the similar manner, there are some standard functions whose nth derivative I can find out. So for an example, I will write down one function and I will ask you the 100th derivative of it. So how do we get such a large derivative of some function? Say y is equal to 3 raised to x. Okay, and 100th derivative of y. So someone from you, can you answer this? What will be the 100th derivative of this function?
3 raised to x into log of into ln of 3 raised to 100.
Ln of 3 raised to 100. So as we can observe, there is certain pattern being followed. Okay, like there is this notation that I'll be using. So when I write y1, it will mean that the first derivative. This is suffix represent number of derivatives. Suffix represent number of derivatives. Okay. So y1 will mean the first derivative. So first derivative is 3 raised to x log 3. Right? So when I take second derivative, that will be 3 raised to x log 3 square. If I take the third derivative, that will be 3 raised to x log 3 cube. So this number of derivative is related with something on the right hand side. So 3 derivatives, log 3 ki power will be 3. So when I say 100th derivative y100, that will be 3 raised to x log 3 raised to 100. Okay. So if I am talking about the nth derivative, so n is just a number. I mean the number of times I'll take the derivative of y. So that will be 3 raised to x log 3 raised to n. So is there only one function y is equal to 3 raised to x? So there are some more functions whose nth derivative I can orally find out. Like if I have y is equal to e to the power ax. So y is equal to e to the power ax is nth derivative will be anyone yn.
A raised to n e raised to x.
So that will be a raised to n e to the power x. So how do we get that? You take the first derivative of e to the power x, that will be a e to the power x. You take the second derivative, that will be a square e to the power ax. You take the third derivative, that will be a cube e to the power ax. So this number of derivatives is related to the power of a. So whatever is the number of derivative, that many powers of a is there. So we have seen just now two formulas. The first one is, so I will make two columns, function and its nth derivative. So the function is e to the power ax, nth derivative is a raised to n e to the power ax. If I have a raised to x, then nth derivative of this is a raised to x log a raised to n. So this is what successive differentiation is. So you find out nth derivative of something and then you use that formula to find out any number of derivatives. Third is a very important one, ax plus b raised to m. So you think of taking derivatives of this function y is equal to ax plus b raised to m. What do you think? I mean, what can be the cases or what derivatives I mean, what answer you can get?
M factorial.
M factorial, okay, and nothing else. Pratik.
Yes, sir, M factorial.
Only M factorial. What?
So m factorial into a.
Okay.
I'm sorry, sir. M factorial into a raised to m.
Uh,
Sir,
Sir, A raised to the power
m
M into M
factorial into a raised to m.
okay. Dhruv, where is Dhruv today? Dhruv is absent. Fine. Where is our other CR? Where is Preeti? Preeti, what do you think?
Sir, no idea, sir. Actually, I have doubt in this topic.
Uh, yeah, doubt. Okay. Okay. So what I will do is I'll take a particular function. Say for an example, y is equal to 2x plus 3 raised to 3. Look, nth derivative matlab you need to find out a formula, a strong formula by which you can directly tell the derivative, any number of derivatives. So in this case, if I take y1, what it will be? So that will be 3 into 2x plus 3 square into, by chain rule, you will have 2. So if you take y2, then that will be 3 into 2, 2x plus 3 raised to 1 into 2 square by chain rule. Y3 will be equal to 3 into 2 into 1. 2x plus 3 raised to 0, which is 1, and this will be 2 cubed. So which I can write as 3 factorial into 2 raised to 3. Y4 will be equal to Pratik. Y4 will be
0, sir.
0. Y5 is 0. All of the further derivatives are 0. So you said about the third derivative, I mean m factorial into 2 raised to a raised to m. But that is just one derivative out of these n. When I say successive differentiation, I need a formula. I mean, I should be able to give, answer for any number of derivatives. Are you getting my point? It's not just about the third derivative or fourth derivative. You should be able to give me a formula which will work for all number of derivatives. So I will make cases in this. Okay, so what I wrote there, y is equal to ax plus b raised to m. So I will take yn represents the number of derivatives. So there will be cases if n is greater than m. Matlab, what is m? M ka significance. You have to talk in terms of significance now. Don't be particular. What does this m mean? M means the power of ax plus b. If your number of derivatives is greater than the power, what is the answer? Prabal,
Yes, sir.
0.
Prabal, if my number of derivatives is greater than the power, what will be yn?
Uh, if my number is greater than the power m, so a power n, um, a raised to the power n, उसके बाद differentiate करेंगे तो
Anirudh,
Sir, 0.
very good. So look, in this you can observe, third derivative was this and fourth derivative, as the number of derivatives is greater than the power of 2x plus 3, then the derivative becomes 0. So what has happened here is m is the power, n is the number of derivatives, it is strictly greater, then this is becoming 0. Now, the other case is if n is exactly equal to m. Yes, anyone?
M factorial into a raised to
M
m.
factorial into 2.
So I can write it down as m factorial into
A raised to m.
a raised to m. Right? Now, the problem is when your number of derivatives is less than the power. Okay, so for that, what I will do is I will find out a simple formula which will be easier to remember or easier to calculate.
So that would be m minus n factorial into a raised to the power
Um,
n.
No, no, no.
sir,
Wait, wait. Whoever it is, just a minute. Okay, so I will put the power m over here. M. Okay. I'll take the first derivative. Let's make this ax plus b. Y1, that will be equal to m ax plus b raised to m minus 1. And you will have a over there. Now, let's take the second derivative, y2. In y2, you will have m minus 1. And you will have ax plus b raised to m minus 2 into a square, right? Then, if I take the third derivative, then that will be m minus 1, m minus 2, ax plus b raised to m minus 3 in cube. Now, if I follow the same pattern, yn will be equal to m minus 1, m minus 2. It will go up to m minus
N plus 1.
who said it n plus 1?
Sir, Rohan. Rohan.
Rohan. Okay. Minus n plus 1. Is it right, or you want to say something else?
No, sir.
No. So bracket shouldn't be there.
Okay, that was a bracket, sir. Okay, I didn't see that. I thought that it was just normal.
Is it right? So m minus 3 plus 1. मतलब minus 3 plus 1 will be minus 2. So this is correct. Ax plus b raised to m minus n into a raised to n. So this is the formula when your number of derivatives is less than the power.
sir, for simplification, the first term can also be written as m factorial upon m minus n factorial too, right?
Yes, yes, it can be written, and that is the easier way to remember. Where is it? It is
Pratik,
Pratik,
sir.
right? You know?
Yes.
So what we have is I can multiply by m minus n factorial. Okay, multiply and divide by. So in the numerator, what we will have m factorial ax plus b raised to m minus n a raised to n upon m minus n factorial. Okay, so whoever is convenient with the this non-simplified form, they can go with it, or you can remember this. It is up to you. So I will mention it in our list. So ax plus b raised to m. So this is equal to m factorial ax plus b raised to m minus n into a raised to n upon m minus n factorial. This is when n is less than the power. If n is exactly equal to the power, then it is m factorial a raised to n. And if number of derivatives is greater than the power, answer is 0. Please note these formulas down, because when we will be solving example, we'll need it a lot of times. Next. So if I have y is equal to 1 upon ax plus b raised to m. So what do we have? Y1. Okay, before going to y1, I can simplify this as ax plus b raised to minus m. So when I take y1, that will be minus 1 into m ax plus b raised to minus of m plus 1, right? Or simply minus m minus 1, which I can write as into a, which I can write as minus 1 into m into ax plus b raised to m plus 1 with minus sign into a. So if I take y2, that will be minus 1 into m plus 1 ax plus b raised to minus of m plus 2 into a square. This would be minus 1 square. Then y3 is minus 1 cube m plus 1 m plus 2 ax plus b raised to minus of m plus 3 a cube. Now yn will be equal to Vipul. Vipul, you want to say something? Anirudh.
Sir, minus 1 की power
Hmm.
n dot m plus 1 dot m plus 2 till m plus n.
Sure, m plus n.
M plus n minus 1.
M plus n.
Minus 1.
Okay.
Into ax plus b की power minus
Just a
m
minute. Minus 1 raised to n m plus 1. This will go up to m plus
plus
n.
n minus 1
Hmm.
dot ax plus b की power minus m plus n
Hmm.
m plus n in bracket dot a की power n.
Very good. So that is the answer. So I will have a particular case over here for this. Since this formula is not of so much of importance, a lot of times this next formula will be used. So I will write it down. What if you have 1 upon ax plus b? So you have 2 minutes. I'll take a break for a minute. You'll find out the answer. Yes, anyone?
Sir,
Huh.
minus 1 raised to n
And just a minute. Minus 1
raised to n
raised to n
times n factorial
times m factorial.
times ax plus b raised to
What do you
minus of
mean by m factorial here? M is not the
m, no,
power.
n factorial, n factorial
N factorial
times ax plus b.
Okay.
Okay, a raised to n into ax plus b
Ax plus b
raised to minus of n plus 1.
minus of n plus 1, which means that minus 1 raised to n in factorial a raised to n upon ax plus b raised to n plus 1. Is it right?
Yes, sir.
By using the laws of indices, ax plus b raised to minus bracket n plus 1 is actually equal to 1 upon ax plus b raised to n plus 1. So this will be used a lot of times. I mean, 1 upon ax plus b, this is of more importance. The previous one that we found out, that is, I mean, quite rare in the examples, but still, if it is there, you can, I mean, derive it at the time when it is required. No need to remember it. So I will simply write down the formula. The next one, 1 upon ax plus b. The formula is minus 1 raised to n factorial a raised to n upon ax plus b raised to n plus 1. Now, just using this last formula, who can tell me what will be the nth derivative of log of ax plus b?
Sir, I have a question. I'm not understanding anything from this equation. Is there a possible way, like you can explain all over it again?
What you're not understanding?
So I'm just not understanding the portion where you just wrote with the ax plus b at the bottom on the dominator of n plus 1 to the power.
Just a minute. Let me just get back to that slide. So you're not understanding how I wrote this. Minus 1 raised to n factorial, a raised to n, right? Is it? Or you have something else? Okay, anyway. Let's get back to what I was teaching. Yes, what I was asking is log of ax plus b. Who can find out
Sir,
the nth derivative of this? Pratik.
sir,
Yes.
minus 1 raised to n minus 1
Okay.
into n minus 1 factorial
Okay.
into ax plus b raised to minus n
Okay.
and into a raised to n.
How did you find? I mean, how you did it, Pratik?
Sir, y1 will be 1 upon ax plus b times a.
Very good. Yes.
And so now yn for yn it's the same question as earlier, but n will be replaced by n minus 1 because
Very good.
last time
Exactly.
suffix 0 we had 1 upon a the original term. So here it is for
Very good.
1. So each term will reduce by 1.
So y1 is actually 1 upon ax plus b into a. Now, everyone, you just look at this. What I need is nth derivative of this. nth derivative of y. Okay, I have found out y1. Y1 is this. Now, how many more derivatives I have to take is n minus 1 derivatives. Taking n minus 1 derivatives. So when I take n minus 1 derivatives of 1 upon ax plus b, we will use the same formula, which was here, this one. So 1 upon ax plus b ka nth derivative is this. What I want is 1 upon ax plus b ka n minus 1th derivative. So that will be minus 1 raised to n minus 1 into n minus 1 factorial a raised to n minus 1 upon ax plus b raised to n bracket complete. There was one more ax over there. So totally what we have, minus 1 raised to n minus 1, n minus 1 factorial, a raised to n upon ax plus b raised to n. I hope the idea is clear to everyone.
Yes, sir.
Yes. Pratik, it was clear to you. Soumya Tripathi, is it clear to you?
Yes, sir.
Chinmay, CS?
Yes, sir.
Okay. Vineet Parmar? Okay. Fine, we will go to the next formula then. Sine of bx plus c. So the formula number is whatever. We'll summarize it at the end. So y is equal to sine of bx plus c. Let's take the first derivative, y1. Y1 is nothing but b cos of bx plus c. B sine in bracket. How can I convert this?
Pi by 2 minus bx minus c.
Okay. Can I write down bx plus c plus pi by 2? Will it work?
Yes, sir.
Bx plus c plus pi by 2. Now I'll take y2, the next derivative of this term. So it will become b square cos of bx plus c plus pi by 2, which I can again convert as b square sine of bx plus c plus 2 times pi by 2. If I take third derivative of this, that will become b cube cos of bx plus c plus 2 pi by 2, which I can again convert as b
3
cube
pi.
sine of bx plus c plus 3 pi by 2. So from this, if I want to take nth derivative, b raised to n sine bx plus c plus n pi by 2. So the nth derivative of sine bx plus c is bx plus c plus n pi by 2. hopefully clear to everyone. The
Yes.
same thing I can do for cos bx plus c. Y is equal to cos of bx plus c. I'll do it on the next page. Y is equal to cos of bx plus c. Y1 will be minus b sine of bx plus c. This I can write it down as b times cos of bx plus c plus pi by 2. Correct? Then again y2 is equal to minus b sine of bx plus c plus pi by 2. Again I can adjust that minus sign, sine into cos. Y2 will be, this is b square, sorry, yes. So b square cos of bx plus c plus 2 times pi by 2. In the similar manner, if I proceed, yn will be equal to b raised to n cos of bx plus c plus n pi by 2. The last formula, which is the most important one, which we never thought could become which would give nth derivative. So the formula is e to the power ax.
So can you show the previous page?
Who wants the previous page? Satej.
Yes, sir. Okay, sir. Done.
Sine of bx plus c. So we'll find out y1. Y1 is equal to, let's take the derivative, e to the power ax. Derivative of sine bx is b cos of bx plus c plus a e to the power ax sine of bx plus c. Now what I will do is I'll take e to the power ax outside. In bracket, what we get, b cos bx plus c plus a sine bx plus c. Can you make some substitution so that this will again turn out to be e to the power ax sine of bx plus c plus some theta?
Sir,
Multiply and divide by root 2.
multiply and divide by a root of a square plus b square. So it will
Very
be in
good.
the form of sine b plus cos a cos b, like that. Or else sine a cos b plus cos a sine b, which will give us sine.
But you will have to do some substitution, Pratik.
Okay, sir, give me a minute.
Where is Ananya?
Yes, sir.
Tell me, what is the substitution?
Just multiply
Then divide by root 2.
No.
Then we can
Sir,
make it in the form of pi by 4.
Yes, Pratik.
sir, put a by root of a square plus b square as theta as as cos theta.
So what I want to do is I want to convert this into the form sin A cos B plus cos A sin B. Okay, so for that, what I will do is I'll put B as something and A as something. So I will put B as sine of theta and A as cos of theta. Or A as, so what we have, where theta is equal to tan inverse of B by A. So what we will have, e to the power ax sine theta cos of bx plus c plus cos theta sine of bx plus c. So which is e to the power ax sine of bx plus c plus theta. Please check the calculations. This is your y1. This I can do second time. If you take the derivative y2, again you will have the same thing. So in that case, what we will do is we will adjust in the same manner once again. Is it right or is there some mistake over there?
Sir,
Mm.
sir, we have to put a by root of a square plus b square as cos theta.
Yes. Root
So
of
then
a square plus b square.
we multiply and divide by root of a square plus b square.
Yes. So that cos sine square theta and cos square theta will become 1. Exactly.
Because a can be greater than 0, so we
Huh.
can't directly put it cos theta.
Hmm. So I'll just write down yn directly. So what will be yn in that case? So we will have, I will call it say r, under root a square plus b square is r. So nth derivative of e to the power ax sine bx plus c, that will be, so yn is equal to r raised to n e raised to n e to the power ax sine of bx plus c, where bx plus c plus n theta, bx plus c plus n times theta, where r is equal to under root a square plus b square, theta is equal to tan inverse b by a. Clear? Priti, is it clear?
Yes, sir.
Okay. Let's go ahead. Y is equal to e to the power ax cos of bx plus c. So what will be the nth derivative in this case? Chinmay? Chinmay, what will be the nth derivative? Anyone who can answer?
Sir, I have a question in the last answer.
Just a minute, huh, Pratik? Satej?
Yes, sir.
Can you tell me nth derivative in this case now? If you follow the same procedure? No. Yes, Pratik, what do you want to ask?
Sir, in the answer, a raised to n term shouldn't be there, right? Sir, a raised to n, because it can't be taken common, so it doesn't arrive there.
Yes,
Because
yes,
for
yes,
each
I'm
term, we
so
are
sorry.
substituting it out.
Yes, exactly. Exactly. R raised to n e to the power ax sin of bx plus c plus n theta. So yn for e to the power ax cos of bx plus c, yn is equal to r raised to n e to the power ax cos of bx plus c plus n theta, where r is equal to under root of a square plus b square, theta is equal to tan inverse b by a. That's it. These are the formulas. We'll just summarize everything and then we will stop. So e to the power ax, nth derivative is a raised to n e to the power ax. You have a raised to x, then nth derivative is a raised to x log of a raised to n. If we have 1 upon ax plus b, yn is equal to minus 1 raised to n factorial, a raised to n, ax plus b raised to n plus 1. Then log of ax plus b yn is equal to minus 1 raised to n minus 1, n minus 1 factorial, a raised to n upon ax plus b raised to n. Then sin of bx plus c cos of bx plus c. In both the cases, nth derivative is yn is equal to sin of bx plus c plus n theta. Yn is equal to cos of n pi by 2. I'm so sorry. Bx plus c plus n pi by 2. Then e to the power ax sin of bx plus c. The nth derivative is r raised to n e to the power ax sin of bx plus c plus n theta, where r is equal to under root of a square plus b square and theta is equal to tan inverse b by a. The same thing works for e to the power ax cos of bx plus c, in which it is r raised to n e to the power ax cos of bx plus c plus n times theta. There is one more formula which is ax plus b raised to m का nth derivative and 1 upon ax plus b raised to m. These two I am not writing down since those are hard to remember. In regular example, these many formulas will be useful. You can take the screenshot of it so that in tomorrow's lecture, next lecture, whenever we will be solving examples, this will be helpful. If you have any difficulties, you can ask. Otherwise, we will stop.
सर
Yes, Anirudh.
सर जो लास्ट दो आपने बताए ई की पावर ए एक्स साइन बी एक्स प्लस सी और कॉस बी एक्स प्लस सी वाले, उसमें जो कन्वर्जन किया उसमें मेरे को दिक्कत है थोड़ी, मतलब मेरी ट्रिग्नोमेट्री थोड़ी वीक है तो मेरे को दिक्कत आ रही है.
वो फॉर्मूला डायरेक्टली याद रखो. It will be better.
ओके सर.
In no of the example the proof is asked. You just have to remember the formulas, all of them. So wherever required, we will directly use the formulas. We don't need the proof. It's just the
ओके सर.
extra knowledge that I have given.
ओके सर, थैंक यू सर.
Oh.
So one doubt, when will you upload the video of last lecture?
Yes, Preeti.
When will you upload the video of last lecture, sir?
I will soon upload the videos. By today evening, they'll be there. No problem. Yeah. Fine then. No other issues. We'll stop.
So we can leave the meeting.